Hello and welcome everyone to this video on getting started with TensorFlow 2.0, and I am Divya Thakur. Machine learning is based on algorithms that can learn from data without relying on rules-based programming. What it means is that if you have a machine, you have your computer, to it you are feeding both the inputs and the outputs, the complete data. And in turn, the machine is developing an algorithm, is developing the insights, discovering the patterns between inputs and outputs. So it's learning itself. In traditional programming approach, the machine is being fed the inputs, and to get the desired output, the machine is being taught what to do and how to do it with the help of if-else, for-while loops, functions, unions and structures, etc. So the machine is being given rules to get the desired outputs. But here in machine learning approach, the machine is being fed both the inputs as well as the outputs. So the model is then trained on these inputs and outputs so that it learns the patterns, develops the relationship between the given inputs and the outputs itself, and in turn forms an algorithm by its own training. Whereas here in traditional programming approach, the algorithm is being fed to the machine. Now, why are we using TensorFlow? That's because it's an open source package developed by Google, and it has all the algorithms that are needed for machine learning. So, but why tensor? What is a tensor? So tensors are the inputs that are fed to a model, and they flow through the hidden layers and also produce an output in the form of tensor. So let's understand it pictorially. So numbers like 1, 2, minus 10, minus 20 are all scalars. When they are arranged in this fashion, that is in one column only, then it forms a vector, or in one row only, then it forms a row vector. Now a matrix is an arrangement of these scalars. They can be floating point numbers as well. So the arrangement of these scalars into rows as well as columns. So here we have two rows and two columns. So it is a two-dimensional matrix. When we are feeding information which is more than which has more than two dimensions. For example, an image which has a red, green and blue channel, because an image has RGB colors. So it has some kind of scalars arranged in a matrix in the red channel, a matrix of blue channel and a matrix of scalars in green channel. So when these are arranged together, they form a third dimension. So this arrangement creates three-dimensional tensor. So over here it has one row, two columns, one row, two columns, one row, two columns again. So when it has been arranged together, it forms a three-dimensional tensor. Likewise, we can have four-dimensional, five-dimensional and more tensors. So these tensors flow as input through the neural networks. So now we'll be building a neural network ourselves. This will be a very simple neural network because it will have only one input layer, only one output layer and only one hidden layer. This is where our model will find out the relationship between the input and the output. So its computation will take place here in the hidden layer, and we don't know what it shall do, but it shall correctly or accurately predict the relationship between input and output. So we'll see that in just a minute. Over here in this Python notebook that I've stored on Google Colab and also uploaded on my GitHub account, the link of which I have given in the description, so do check it out. In this Colab, I have used two approaches, the first one being the traditional programming approach and the second one being the machine learning approach with TensorFlow. So over here, suppose I have this equation of the function y equals to 2.5 times of x plus 3. Using this equation, I can have these sets of inputs. Suppose my x is -10, -5, 0 to 150. So I have these 5 sets of inputs. And my y, according to this equation, is -22, -9.5, 3, 8, and so on. So suppose I have this equation ready with me, and accordingly I've selected the inputs and the outputs. So suppose to this function, I'm taking the input as x equals to -10. So let me run this cell. Now I'm feeding the machine, my computer, this algorithm, which is y equals to 2.5 times x plus 3. I already know this relationship between my input x and my output y. And I'm feeding the same thing, the same algorithm to my machine. So I fed the input, I fed the rule, I fed the algorithm, and now I want to know the value of my output. So let me print x and y. So x is -10 and y is -22. That matches the table here. But what if we don't know this relationship between the input and the output over here? And we cannot, suppose you have to identify a cat and a dog. How will you establish the relationship? You know that you can identify a cat and it has certain kind of features, but how can you make that machine identify a cat and a dog? Because consciously you don't know the rules. So you are letting the machine do its work. So suppose for the same equation, 2.5 times x plus 3, and I have these inputs and respective outputs, I'll do this thing. I'll define my network, I'll compile the network. Network, as I had explained, will have one input layer, one hidden layer, and one output layer. Next, I'll fit that network to the given inputs and outputs. Then I'll evaluate the network, its performance, and then I'll make predictions accordingly. So for that, I'm importing TensorFlow library and giving it an alias of TF, and also the NumPy library and giving it the alias of NP. Next, I am deleting any kinds of warnings except for errors. So please log only errors, not warnings for me. So let me run this cell. Now I'm feeding x and y's, that is my inputs as well as the outputs, to my model in a form of NumPy array. So I have these inputs, the d type is float, the data type is float, and these are my outputs, and again the data type of these is floats. So let me run this cell. Now let me print the values of x and y to know that the values of x and y have been correctly fed. In order to build a simple neural network with one input layer and one output layer, we have come so far that we have our input layer ready in the formation of x and also our output layer in the form of y. So we have these two layers ready. Now we have to work upon the hidden layer. So for that, I have over here a variable named layer, and it's deriving a dense layer from the TensorFlow Keras API. The unit is 1 because we are building a simple neural network which has just one hidden layer. So the unit is 1, and the input shape is one-dimensional tensor. Because our inputs are x and y that are also one-dimensional tensor. So our hidden layer will also be a one-dimensional tensor. Now we'll be defining the model. So the model works in this way that each input is fed sequentially to the hidden layer, and then the result is computed and we get the output. So each sequence of input has its own weight and is important. So the model that we are building over here is a sequential model, and it's taking the variable layer that we just formed, which has 1 unit and input shape is 1. So let me run these two cells of the variable layer and of a model. So now we have defined a model, and now let's compile it. So for that, the loss that I've taken is mean squared error. If you're not comfortable with what this loss is, you can check out my video, the link to which I have provided over here in the description. And I'm using the optimizer, which is Adam optimizer. You can also use stochastic gradient descent. And the learning rate I have taken as 0.1. We'll discuss more about this in the coming videos, so don't worry. And you can also check out the documentation over here. So you can go over the documentation, control plus click text, and then you will see. So let me also run this. Now we are training the model. That's the most important thing. So we are training the model over the input X over here, and we are also feeding the output Y, and we are training it 100 times. So for 100 times we are training the network so that it can correctly establish the relationship between X and Y, and verbose is false. So I am storing this trained model in the variable train, and it will take some time because it will run for 100 times. Now let's evaluate the model. So remember, I have taken the loss as mean squared error and optimizer as Adam with a learning rate of 0.1. So it will plot the loss for me. So this train variable has a history, that is, in the first epoch, what was the relationship it derived between X and Y, and was it a correct relationship or not? Then what happened in the second epoch? Then what happened in the third? How much correctly it has reached in at the 100th epoch is what we will see with this graph. So see over here, the loss was very high during the first 40 epochs, and then it decreased and is about 0 only. So now let's make predictions from this model. So let me show you over here that the table that we had taken. So I had -10, -5, 0, 2, 100 and 50. So I had 6 inputs and 6 outputs. But over here I fed only 5 inputs and 5 outputs. So I have one more input and one more output over here. So the input is 50, x equals to 50, and I'm getting my y as 126.5. So let's see what this model is predicting. So if I'm passing 50, so my model.predict is giving me the answer, that is my y, as 127. Okay, so the correct answer is 126.5, not bad. So let me see what it is multiplying with x. So it's multiplying 2.47 with x and adding a bias which is 3.13 to get this result 127. This is how a model can make its own algorithms and establish a relationship between the given inputs and outputs. And this is the machine learning approach which I just discussed with TensorFlow. You can try it on your own and also have a look at the collab. This is all, and please subscribe to my channel for more such videos, and give it a like if you liked it, and thank you for watching.